Okay, so today we're going to learn how to write the equation of a line given some sort of information. Now before we get going here, I wanted to do a little bit of review of the forms of linear equations that you've learned so far. Okay, so we start off and we have standard form, and it's just a nice pretty form where there's no fractions in it. It's kind of cleaned up. It's great for doing algebraic computations and some things that we'll do later on. It doesn't have great use as writing equations or being able to graph and that kind of thing, so we won't use it a bunch. Slope-intercept form, awesome for graphing. You got to know the slope, you got to know the y-intercept, and you can graph it real nicely. It's a decent looking equation also, and so this is actually the form that we usually will answer in. Now, the problem with that is that you have to have that y-intercept. And a lot of times we don't know what the y-intercept is. So we have the third, and this is the final one, I promise. Final form is point-slope form. And this one works great if you're trying to write the equation of a line, which is what we're doing here today. You have to know a point that your line goes through. You have to know the slope of your line, and then you can put your equation in slope or into point-slope form. Now, it's great for writing it because you just fill in the numbers real quick. It's a little bit messy looking, so rarely do we leave it in point-slope form. That's kind of what we start off with, and then we'll go and convert it and put it back into slope-intercept form. So here's our slope or our point-slope form. This is what we're going to be using today. On this example then, we're trying to write the equation of the line, and it does say to put it in slope-intercept form. So my final answer will be in that form, but that's not necessarily where I start. It tells me that the line has a slope of -2, and it passes through the point 6, -5. So this is a perfect example because they give us the point that it goes through, and they give us the slope. So those are the two things we need to use this point-slope form. So the point-slope form, remember, was y minus y1 equals m times x minus x1. Now remember that those subnumbers are just there to distinguish between which x you're talking about. And actually, what we do is we leave the original, just the x and the y, those stay in the equation. Because remember, in your equation for a line, you always want to have an x and a y in it. So those stay put. The x1 and y1 are going to get replaced with the x and the y from our point. So there's your x and your y. Your slope up here is your m. Let's just plug in the information. So the first y stays put, minus the y from the point, so that's a -5, equals the m is -2, and then again you leave your first x minus the x from the point. Okay, and then that's point-slope form, but we want to clean it up. We want to put it in slope-intercept so that it'll have the y by itself. So the first thing I do, okay, that's going to be plus plus. Let's distribute the -2 through the parentheses. So you're going to have y plus 5 equals -2x, and then -2 times a -6 is going to be a positive 12. And then move the 5 to the other side so that the y will be by itself. So y equals -2x plus 7. So using that point slope usually works pretty quickly. Now this one was kind of nice because the slope was pretty. I know that on the software a lot of times they don't give you a nice pretty slope like that. So let's try one that doesn't come out quite so beautifully. Same question, only this time my slope is 2/5, and it's going to pass through the point -1, 4. Okay, so one more time. Point slope form is y minus y1 equals m times x minus x1. So let's start filling in our numbers. The first y stays put minus the y from my point. Remember that this is my x, y, and this is my slope. Okay, so y minus 4 equals 2/5 times x minus -1. Okay, that's going to change to plus plus. So let's distribute that 2/5. So then you'd have 2/5 times x and a 2/5 times 1. And then you just got to move that 4 to the other side. So y equals 2/5 x. And here's where it gets a little bit messy, is trying to add that 2/5 to the 4. Now, you can write it as a mixed fraction, but we rarely use mixed fractions in algebra. It's hard to do computation with them, so don't write it 4 and 2/5. Instead, what you'll do is you change this 4 as a 4 over 1. Think of it like that. But I can't add 2/5 and 4 over 1. I need to have a common denominator to add those fractions. So what I'm going to do is I'm going to change this. I want this 4 over 1 to actually have a denominator of 5. So take your denominator times 5, take your numerator times 5. So 4 over 1 is the same as 20/5. It would reduce to the same thing. But what's nice is now I can add these two together. 2/5 plus 20/5 is 22/5. Well, let me change the color on that. Go back to my pink. So it'd be plus 22/5. So really it's just that last step where that fraction gets a little bit ugly, but if you can just get a common denominator, you add them together, it works out fine. Alright, so let's try an example where they don't hand you exactly what you need. They don't give you the point and the slope. In this example, they give me 2 of the points that my line will go through. They don't really give me the slope. Okay, so that just means go back and use your slope formula and find the slope. So remember, slope, m equals y2 minus y1 over x2 minus x1. So you're going to subtract your y's, subtract your x's. The order doesn't really matter as long as you're consistent. So I'm just going to go with, let's go with a -7 minus a 5. That's my y minus y. Got to stay consistent. Since I started with -7, then I got to start with 1 minus -2. Clean it up. -7 minus 5 is a -12. Over, this is change to a positive, so that's a 3. And that actually reduces nicely. So my slope is actually going to be -4. So that's going to be helpful, but I'm not done. All I've done is really found the slope. Now I can use my point slope form. I'm in luck because they've actually given me 2 points, but I don't need both points. I only need one of them, and it doesn't matter which one you use. You can use either one. You'll get the same answer. I usually just pick the one that looks the prettiest. Maybe you like smaller numbers. Maybe you like to avoid negatives. Whatever it is, you just pick one of the points. So I don't know. I'm just going to pick this point. So I've got the slope right here. I've got this point. And now I'm going to go do my point slope form. So y minus y1 equals m times x minus x1. Remember that you leave the first x and y there. So this y stays put minus the y from my point equals m is my slope. Leave the first x there and replace the second one with the x from your point. Change that to a plus plus. Distribute the -4. So -4x. -4 times a +2 is going to get me a -8. Let's add the 5 to the other side. And we end up with a y equals -4x minus 3. So that's what's different if they give you the 2 points. It just means you have to work a little bit ahead of time to find your slope, and then you work through the process the same way. All right, let's try one more, last one. Same thing as last time, only probably not going to end up quite as beautiful. Let's try it. Okay, so I've got my 2 points. got to find my slope first. Slope is y2 minus y1 over x2 minus x1. So always put your y's on top. One of the most common mistakes I see is that we get our x's put on top, but it's rise, it's your up and down, it's your y value over your x. All right, so I'm going to go, doesn't matter which one you start with, I'll start with the 2. 2 minus negative 5. Those are my y's. And then since I started with the 2, I'll start with the 6 minus negative 3. And then you clean that up, and it looks like I'm going to have a 7 over 9. That is not a very pretty slope. 7/9. When I look at my 2 points, I guess what I would like to avoid maybe are the negatives in that point. So I'm going to go with my 6/2. You can try the 6/2, you can try the -3, -5, whichever. So then we go to our point slope form, because now we know a point and we know the slope. Leave the first y there, subtract the y in your point. Equals, your slope was 7/9, and then you do an x minus the x value. So here's where you distribute, and I know it's not going to be super pretty, that's alright. 7/9 times x is just 7/9 x, and then on this one I have to take a 7/9 times a 6. Now remember, I'm multiplying here. I don't have to have a common denominator to multiply, and if it helps, write your 6 over 1, because when you multiply fractions, you just multiply them straight across. Now I'm taking a positive 7/9 times a negative 6 over 1, so I know it's going to end up a minus, and multiply straight across, so the 7 times the 6, like this 7 times this 6 gets multiplied, this 9 times this 1 gets multiplied. So I'm going to end up with a negative fraction. It's a 42 over a 9. Okay, looks ugly. Now I have to add the 2 over here to it. But remember, to add fractions, I need to have a common denominator. So I'm going to change this 2 over 1 that I'm trying to add, and I'm going to turn it into something with ninths. So I want it to be a 9, so that means take the 1 times 9, take the 2 times 9. So 18/9 is the same thing as 2 over 1. Alright, so then it gets a little bit trickier because you got some bigger numbers. You got a negative 42/9 and a positive, because we're adding this, 18/9. So those are different signs, so you're going to subtract them. And it's going to end up a negative, and 42 minus 18, what is that, 24? So there is your equation. Y equals 7/9 x, kind of an ugly slope, minus 24/9. It's also an ugly y-intercept. Typically, though, we're not going to try to graph those. We're just trying to get that equation written. So sometimes it'll end up ugly. That's okay.